On the bench today we have a pair of early digital clocks. Caringella electronics. The one on the right we have discussed. See the prior video, I'll link that below. It's the Caringella or CEi DDC-1. It's a 6-digit Numitron clock. Put that aside. This is our featured guest today. This is a Caringella Electronics or CEi SDC-1. Again, Numitron tube clock. You may remember if you saw the video. If not, the video that I will link below for the other clock discusses in detail a little bit of the history of Caringella Electronics, and I was told that they beat most of the digital clock kits out there one could buy. We're talking early 70s. Even they beat Heathkit by a year. So we're talking these guys did it first. Especially, you know, if you're looking at you're into this hobby, the Nixie tubes and stuff, the single-digit clocks that you're seeing now. Here's the original one right here. Digital was just coming out. Caringella, Charles Caringella and Michael S. Robbins worked together, and they turned out quite a few products. The one that you just saw, I slid off to the side, and this one. They also, you can see this one. They had a few others. That's an old radio electronics article over 3 months. It starts in January '75, in case you're interested. You don't see these every day. So we have this little book here. This is by Michael S. Robbins. Okay, again, he worked with Charles Caringella, and in this book is featured this clock, which is pretty neat. There's a block diagram of the electronics, and this uses the MM5314 4 or 6-digit clock chip that we've discussed many times on this channel. The interesting thing with this single-digit clock arrangement and using that chip, it's a multiplexed output, and it scans seconds, minutes, hours, sequentially. So that's fine when you're looking at a 6-digit clock or a 4-digit clock. It's scanning so fast you can't see. They had to do some trickery to make it work in this clock. Basically, you had to simulate or get it to read hours, and minutes. Now the seconds are not displayed, and that's the pause. So how they did that, in this schematic, which is going to be a little difficult to show here. Here's your MM5314. Q3 is a UJT, and that's connected to pin 23, the multiplex timing input of the 5314, and that runs about 100 Hertz normally. And with the addition of some additional circuitry here, with that running at about 100 Hertz, that's also clocking this IC over here. It's a 7490 set up to divide by 5. Alright, and every 5th pulse, to slow this Q3 down, acting as a relaxation oscillator. Slow it down to 1 Hertz and then turn on the display. Okay, so the 5314 is generating its normal digit scan, seconds, minutes, hours, but the additional circuitry slows it down and turns on the display every fifth number. That's so you can get the hours, and minutes. Alright, so the seconds aren't displayed, they're not turned on, as this chip does have seconds, but that's the blanking period in between. So right now we're seeing 5:38. We're only seeing ones of hours. We advance the time, then you see tens of hours as well, and it would be just blinking 4 different digits in that case. So it's a little quick rundown, a little bit more of the circuitry here. The digit driver outputs have diodes on them, and they're acting like an OR gate. And then you have 2 diodes down here acting like an AND gate connected to the output enable, and that's what controls the display on and off. So that in a nutshell is pretty quick how that works. Let's give a tour of this thing. Well, we have it up on a bench here. Walnut sides, freshly cleaned up. And we just have our typical slow and fast set, a 12 volt AC input through a terminal strip, which is a very unique characteristic of these clocks. Just a little close up so you can see. And to get the filter off, normally you have to remove a side and slide the filter out sideways. But for the sake of this video, I can pop that right out, and you can see the wonderful display tube. We'll bring this in. Now you can see the 5314 on the right. That's a 1972 dated one, and it's got the early gold pins on it. The filter capacitor really deserves to be changed out because of its age. I did test it. It seems pretty clean and on spec, so but because of its age I may change it. That way 10-20 years from now this clock is still guaranteed to work. There is an IC package to the left of the tube. That's the 7490. Okay, and that's what's doing the trickery to make the 5314 operate as a single digit clock. A couple added diodes up front which control the display brightness. It's like an afterthought. And somebody also added a 10 ohm resistor in the back. So when I received this clock, the display tube that was in it was faulty. Somewhere around here I have that put aside, but anyway, it looks just like this one, and it only had 2 segments working on it. So when I initially fired up the clock, it's just blinking weird things. So the first thing I did was remove the tube, tested it, found it was faulty, slid in another tube into the socket, and she was up and running. It's beautiful. So I was happy to see that. Not too much work for the old bad neck to be hanging over the bench at this point, so we're working on that too. Oh, what else can we say about this gem? Again, early digital clock. This has got to be the first single digit clock ever made, and it's an opportunity to have it in my possession. I was very happy to work out a deal with the seller. The seller appreciated it for its age and style. So I have to thank him for letting me have this opportunity to own it and go over it, clean it up, and get it out for all to see and learn from. So thank you for watching. Hope you enjoyed the video. And if you have old vintage digital clocks, especially from the hobby magazine era, reach out to me if you want to find a new home for it. We can talk about it and see what it is. Maybe work something out. Thank you very much. Enjoy. Have a good day.